So we have Kunal, the CEO and co-founder of Unravel. How are you?
It's very good to meet you. Thank you. Doing great. Thank you for having me.
Yeah, it's you enjoying the event, you're having fun?
The view behind you is fantastic, so I cannot complain at all.
Yeah, it's we are having a great place here. So I want to illustrate people about the data platform. So because we are seeing a lot of talk about Snowflake, BigQuery, Databricks, all these platforms. Can you illustrate the audience a bit more about what's the main difference between the normal CSP workloads and a bit more about where are the main problems that these platforms have on the cost side?
Absolutely. First of all, great question, and thank you for having us here. So the data platform spend, which used to be a small spend on the total cloud spend, less than about 5 to 10%, only like 2 or 3 years ago, has now become 30 to 50% of your total cloud bill. So that means it's becoming a very big portion, and that also means it's growing very, very fast. And it does not show any signs of slowing down.
Yeah.
But the question you asked is very interesting, because I was at the FinOps X conference right now, and a couple of people who were talking to us about, data FinOps. They think about optimization on this the same way they think about cloud FinOps, which is, hey, if I go and buy a 3-year program, then maybe my cost will go low. Or if I go and pre-buy certain reserved instances, then maybe my cost goes low. I mean, it's a new field, so people don't know about it, but it's completely the opposite. There's a lot of new nuances with, how data spend, and when we say data spend, it's this data analytics and AI platform spend, really. The Databricks, the Snowflakes, the BigQueries of the world. Their spend is driven by workloads. It's driven by the data itself. These are data platforms, so the storage is a big part of it. And if you don't have workload awareness, then you don't know what you're doing, is that you're doing it correctly, or if you are misusing those resources, if you may, right? So a couple of examples, if it doesn't make your head spin. One is how you're scheduling those data pipelines and what kind of code you're actually running on your data, queries, or the kind of models that you're creating on top of these can have a very dramatic difference in effect. You can have one query that produces the same results that runs in 5 minutes, and the same query could run in 5 hours.
Yeah.
And the difference is how that query was written. And not a lot of people know how to write the best SQL, or they may not be aware that they're doing inefficient work on top of those platforms. And that time and that processing ultimately leads to spending more dollars on these platforms. So we see a lot of wastage in whenever these teams start scaling up on these ecosystems. Typically, customers will see 30 to 40% improvement on these platforms, which is very, very dramatic.
Yeah.
We're not talking about 5% here and 10% there. And you really have to look at the whole ecosystem. You have to look at what's happening at the code level, like you spoke about. Then you really have to understand the storage itself. How are these tables partitioned? What's the file format? All of those things affect both performance and cost of these things. And then the underlying infrastructure itself. And in this case, the infrastructure may be abstracted like a SaaS service. Or you may have dedicated containers to run your data apps, if you may. But really understanding what the supply and the demand is and making them meet together is really the name of the game. And that drives a lot of savings for these guys, right? But again, it's a new field, so we're happy to educate everybody around it.
Yeah, definitely. I think the switch, when I read the Snowflake blogs and to feature in the newsletter, and all this is about the query. It's always about focusing the query, how the query is written, how many data are you retrieving, because we are playing here with like big amounts of data that we, like developers that are used to playing with SQL for your queries, designing like an application, but here you're playing with hundreds of gigabytes and
petabytes of data. Yeah, exactly.
Yeah, it's a lot.
So if you do a select star on a petabyte, it is going to cost you a couple $1,000s to run, if not more. So knowing how to select just the data that you want, as an example, improves both speed and cost.
And moving on to like the FinOps side of the equation. So how you can apply, how you get visibility on these platforms to know how much are you costing and how the queries are optimized?
Yeah, it's a good question. So the framework's the same. You have to know where money's going, inform. Then you can figure out where money's being wasted, and then you can do some optimization. And then how do I proactively put guardrails and governance around these pieces, right? Same framework as FinOps, but a very different world. So if you think about the cloud stack and how many users actually submit applications on top of it and how many applications run on it versus what's happening on the data stack, the difference is like 1,000 times. So you have everybody in the company who's given access to Snowflake and Databricks now. So it's not just engineers, it's the marketing team, it's the finance team, it's the product team, it's the legal team, because the companies say, look, we want to democratize the data. We want to give access to everybody. So you should be able to look at your company data and be able to do whatever analytics you want to do on top of it. So therein, there's a big problem. Not everybody's an expert. Not everybody's creating problems in this environment. The other piece is when you look at just the scale of these things, like we were talking about the data sets themselves, it's not a gigabyte, it's a petabyte or maybe more.
Yeah.
We work with companies who have hundreds of petabytes of data right now. Then how do you do the optimization? Where do you go and figure out where the problems are? Because the applications, the data pipelines and the queries, I'll give you an example of scale. There is a e-commerce retailer that we work with. They submit 40 million queries a day.
That's some amount of queries, right?
Where do you even get started?
Yeah.
How do you even know which ones are inefficient? And great, if you know which ones are inefficient, are all of them worth acting upon? So you have that challenge. You have a very big scale challenge. And then governance, of course, becomes a challenge too, because you have thousands of peepers, millions of queries, millions of jobs. How do you solve this messy problem, right? So number one is visibility. And visibility needs to happen in business context, which is, hey, if it's this cluster and this is how much it costs, it's not useful to me. It's more useful if you're able to tell me Victor costs so much money on this cluster. And Victor submitted these 180 queries, and then doing the correlation between all of the different layers of the stack. So if I'm able to find out, these are the queries you ran, these are the data sets that those queries touched, and these are the resources that your queries consumed, then I have the whole picture, because now I can at least tie up all of these different elements to one single entity, if you may. Then you start asking the question, okay, whatever Victor was running, is that efficient? And for that, we have developed algorithms over the last 10 years, which actually go and hunt for inefficiencies. It tells you if something can be quicker, if something can be cheaper, if something can be made more reliable. And we then surface these with an impact next to it so that you can then decide if it's worth taking an action on. So if you had your 200 queries, you could speed one up by 50%, but the remaining 199 of them are only speeding up by like 2%. Do you really care? And then one saves you $50,000 and the other one saves you $50. Of course, you want to go and act on the $50,000 one. So that attribution of finding the problem, then finding the impact of solving that problem is a key part in motivating people to want to do something about it. And then, of course, with autonomous technology, can we now get to autonomous enforcement rather than manual policing, so that people actually are able to see the benefits of all these changes inside their environment, right? So it's a very unique problem. And honestly, if you're not able to give that transparency to that person and let them know that they're doing something wrong, chances are they don't even know, right? Yeah. They're just going on about their day, and they're like, I don't even know I caused that problem.
Yeah, and it's also because it's not their, it's not, of course, their fault. It's because they are not incentivized to optimize that. They are incentivized to create features, to make them secure, to deploy new things and bring value to the business. And they are not saying, they are not enforced to say, okay, how much is this costing? That's a question that comes super after in the development pipeline and not early where it should be, because
Correct.
It will prevent you a lot of the issues that you're saying, right?
And that's why, like for us, whenever we provide an insight or give you that fix, the chances are that it fixes performance and reliability along with cost. And that's the beautiful part about the data workloads.
Yeah.
Because if you're spending less money, chances are you're doing some smarter way of processing that data.
Yeah.
Which means it's actually running faster for you, which the developers do care about.
Yeah, that's a frame that I got from interviewing Rick from AWS.
Right.
He always frames like the compute optimizer from that to being like, we are optimizing performance and therefore we are optimizing cost, right?
That's right.
And especially because I've played a lot with SQL.
Yeah.
And when you are learning that at the beginning, it's more about doing the query. You first want to get the data.
Correct.
Like and any form, like the query needs to work and retrieve the right data, and then you optimize it so that it's faster, because especially with SQL and also especially with NoSQL, because the index doesn't work the same thing, you need to be very to the point, and when you are dealing with petabytes of data, the query needs to be probably the best, world-class thing, right?
And not a lot of people know that.
No, and it's also very difficult, right?
Yeah.
It's not easy, because if you play with that kind of query models,
correct,
it's like, I feel like it's a scripting.
Right.
Like you are doing like a big sentence that it's making a lot of things in a single or bundled thing, and it's not easy to interpret, and it's very unique.
And
right?
honestly, it's not just the users, but the companies are caught up between this as well, right?
Yeah.
Which is like, how do I go tell these users to save money when I've already told them to go innovate?
Yeah.
And I cannot find 1,000 SQL experts or Python experts or Java experts to go and create these data apps and data pipelines for me. So one of the things that we do uniquely in Unravel is we actually explain to you what the problem is in plain English and tell you why something happened and how you can go and solve that problem. So it kind of becomes like yes, it's fixing the problems and getting you the improvements, but you're also learning through it. Mm-hmm. So one of the things that we see is, one of the metrics that we track is the number of problems, have they stopped reducing? Do we see a reduction in repeat problems over and over again? Mm-hmm. Because you see a problem like, say for example, a data skew problem, and you're like, what the hell is data skew? And then we explain it to you, and this is what happened, and what you should do about it. Then we see that this person does not make that mistake the 4th time, the 5th time, the 6th time. And that also becomes sustainable gains for the company, because now you're not seeing that similar problem popping up again.
Yeah, that's true. Like if you, like sometimes people need to, when you are debugging things in any aspect, is that you need a lot of context and a lot of information to know what you need to do to fix it. Yeah. And then it's like if someone or something provides you all that information, like here's what happened, here's what you should do to fix it, here's how you can improve for next time, or what's the source, and it will reduce a lot the amount of time that you need. And wanted to follow up on that. So we always talk in FinOps, and especially in this, about the execution gap. Like you get the information, and then there is a room for you actually need to implement that thing on the context. So what is your advice about how to reduce that execution gap?
It's a great question. So again, you provide the visibility, that's not enough, because we don't have experts in this area, especially in this data AI area. And then the other problem is it's a very complicated piece of technology. Anybody that's run a Spark job or a Kafka pipeline, or a multi-step data pipeline using dbt and Fivetran and Snowflake will tell you that, man, it's going to take you hours to go and figure out where the problem was. So it's a good step to get visibility, and then it's a better step to do the correlation, and that's an even better step to get insights and recommendations. And that do get you to a good spot. But I think real implementation starts to happen when you start to have autonomous enforcement around these things as well. So it's a mix of human in the loop and autonomous enforcement that we usually see in the enterprise scale that we work with. And I'll give you a couple of examples. So if there is something that affects a dev environment or a staging environment, then now companies are getting more okay with saying, hey, just autonomously fix it. I don't need to review and understand, as long as you can build the trust and show me that you're not going to do the negative pieces, which we've taken as a very serious product feature in Unravel, which is what we call the Watchdog. So every time we do a fix, it's monitoring and making sure that the fix is healthy, that you're getting results that are green and it's not red. And, maybe it's green today. Maybe in a week, it's a dynamic environment. Something changes that affects this. So as soon as it starts trending towards negative, can we, just turn it down, or can we turn it off, so that the impact's always going to be green? And once you start showing that to the enterprise, and they go, this is safe, this is clean, this is good. But then, maybe, so one another piece that we do in Unravel is, instead of recommendations, we're giving you actual fixes, even for the code, which is a very unique piece that we do. And what I mean by that is we'll scan your full code of your major data pipeline, and we do find the bottlenecks and we do do the recommendations, but now we're rewriting that code for you and telling you, don't run this code, run this rewritten code. And that rewritten code is not presented to you before it's validated. So we actually take that newly generated code, simulate it, run it, and make sure that, number one, the results are the same as the previous code that you were trying to run. Because we've tried to do these things with LLMs and things like that too. If you just throw your code in there, tell Claude to optimize it or ChatGPT to optimize it, 6 out of 10 times you'll get it wrong.
Yeah.
And that's a big number. And the thing with LLMs is it's always confidently wrong.
Yeah.
It will just tell you, go and do this, right? And then you go and do it and you learn that I'm not even getting the right results. I was looking for sales by country and it's giving me sales by product. Like, what is going on over here, right? So we made sure that validation loop gives you the right results. And then it gives you results that are faster or cheaper or both. And that validation then gives people the trust that, okay, I don't need to try this out and then do this. I can trust it, I can apply it. The Watchdog is watching after this to make sure that nothing changes and I'm still meeting my SLAs and I'm reducing my costs and making sure this thing runs properly. So it's a bunch of these different pieces that you got to put together to actually have the enterprise be comfortable with doing autonomous optimization. I mean, that's the whole thing, because people would love to have machines do their work, but it's the trust factor that ultimately keeps them back. Another company, I'll give you an example, they said, it's good to do the autonomous piece, but you have to follow my company's process. And the company's process is, whatever change we make, let's go make it in dev. And then once you make it there, validate that works there, then take it to staging and then to prod if this test passes. So we actually complete that entire loop instead of just giving you a recommendation and saying you go figure it out. And I think that's the difference in getting these things applied. Another one is thinking about the user workflow and making sure that you are an addition to that flow, but in the flow, that they don't have to come to Unravel. So whenever we're doing, like, say, code optimization again, devs will actually hook up Unravel with their GitHub. And as they're doing code reviews and they're doing a pull request, the Unravel's new generated code shows up there. So this is a great place for that dev to say, now I understand why it's telling me these 3 changes. It makes sense for me. Let me go push this code in production. So poor quality code never hits production in the first place. So it's a great autonomous as well as a prevention story, because you're keeping your cluster healthy and everybody's being good citizens on this platform. And then, of course, like, making changes on the infrastructure side is a little simpler because you don't have to deal with thousands of users. It's a platform team that's maybe a half a dozen people or a dozen people. They do usually have the rights and the controls to change the compute, to look at storage, where you can get massive efficiency gains. In Snowflake, for example, they have a t-shirt sizing.
Yep.
You know, I think it goes all the way up to like 6 extra large. And then in Databricks, it's DBUs.
Yeah.
And it's DW SKU. So everybody speaks their own language. And every one of these has different ways in which you can improve the costs. The supply and the demand match. So in Snowflake, for example, if you're running a 3 extra large size warehouse, of course, if you make it medium, it'll cost you less money. But what's the trade-off? The trade-off is your performance is going to be poor. How do you balance the two? So we have those algorithms that do that data science to help you understand that that's the right fix. And that's really a dynamic allocation of resources. So you cannot just make it 3 extra large to medium. You've got to think about, again, the workload. What's the workload on Monday? What's the workload on Tuesday? What is it at 8 a.m.? What's it at 4 p.m.? And then you really get the graph of understanding that Monday it should be extra large, then it should be 3 extra large, then you can terminate the cluster, then you can start off with a medium, and then you can do this up and down. And that really gives you the best balance between cost and performance, where the users don't start complaining about, I don't know why you guys are saving so much money, my jobs are so slow now,
Yeah.
right? So this eliminates that problem, and again comes back to building trust and capabilities inside the enterprise, where they say, this works because this actually helps me reduce my cost without the friction of the end user teams.
Yeah, and you made a really great point on the sizing, because I read the other day, I don't recall, like it was 2 weeks, 3 weeks ago, that some people save money by making their Snowflake bigger,
Right?
Because of the performance improvement, because the queries take less, and then the
Sure.
adjustments and the balance was that.
Yeah.
So it's a very curious environment, and I really want to see more evolution on that. Right?
And it keeps changing every day, right? So that's the other thing, is why we exist, is to help you simplify all of these complicated pieces, right? So Databricks used to have 2 SKUs. They used to have an interactive cluster and they used to have a job cluster. And now you've got plenty more. But just on the interactive and job, interactive clusters were really designed for figuring things out, for experimenting, for adding a new data source, for trying out a new model. What it was not meant for is to schedule a job that runs every day at 6 a.m. That's why these other things called job clusters exist. Who knows that? Nobody knows that. But interactive clusters cost, I think, 3 times or 4 times more money than job clusters for the same work. So we go into customer sites, we ran a scan on that environment and we saw that half your jobs run every day. These are like maybe upstream jobs collecting some data, doing certain things. Why are you guys running them in interactive clusters? They're like, why we should be running it somewhere else? Like, yeah, you should be running it in job clusters and saving 75% money right off the bat.
Yeah.
So something's just come in the architectural, category, if you may. But it all comes down to having that knowledge and being able to pass that knowledge proactively enough so that people can actually do something about it, rather than, I've already spent the money, I've already spent the DBUs, I've already spent the credits, now what do I do about it?
Yeah, we're already late, right?
Exactly.
So I want to dive more into the autonomous, because most of the FinOps X this edition is talking about AI autonomous. I think most people are still figuring it out, but there's a lot of talk, especially with the token thing.
Yeah.
So what is your perspective on these autonomous implications of the AI in the data platforms, and how do you see it evolving? Because we are in a stage where now we are seeing agents, your autonomous implementation, but what's your forecast? What's your vision for that to happen?
Look, more users, more apps, more data, more problems. And it's as simple as that. And tapping somebody's shoulder and saying, go fix that, it's not going to work. Or brute forcing your way through this at this scale is not going to work. We have customers right now that used to spend $1 million in Snowflake are spending $25 million in Snowflake. We've got customers who are scaling up to $80, $100 million in Databricks and Snowflake a year right now. And if you look 2 or 3 years ago, they were less than $5 million spent on these platforms. So it's not reducing. And everything is growing. Not just the size of these platforms, the number of apps, the number of users. and the number of different types of business outputs that these platforms are generating. So we were at the Snowflake Summit last week, going to be at the Databricks Summit next week. Everybody's talking about AI workloads as the next big workload now. And we're not talking ChatGPT and Claude on its own, which a lot of companies are using for sure. Because the company's data resides in Snowflake and Databricks, you're going to see really big AI workloads being run on top of these platforms. When you and I run AI, our data is in Google Drive, right? Or it's in Salesforce, or it's in a couple of platforms. It's easy to connect all of them to an MCP server and you're ready to go. But you're working with the biggest pharmaceutical company in the world. You're working with the biggest banks in the world. They've spent all these years putting their data in this governed place on a data lake. And that's where you're going to be running all these AI. So that explosion is already happening. And the music is going to stop as soon as the funds run out. And that's going to happen with every company where, I mean, you're already seeing the cracks where people are like, I didn't know that we had to spend $50 million on this thing. Show me the ROI. That's code for, I'm going to turn this thing off if the cost don't go down or the value doesn't come up. So it's both sides of those equations that we've got to sort out. So what do we do? Well, you've got to take the slices of these problems, either in the stack way, like what can we do on infra? What can we do on storage? What can we do in the middleware? What can we do on the app side? And which of these things are completely off limits that you can never do autonomous? Maybe the technology is not there yet. And by the way, if anybody tells you they can make everything autonomous, right off the bat, they're lying, right? And then what are some company level pieces that keep things from becoming autonomous? You go into these major enterprises, they've got these rules of change and you cannot change anything, so autonomous agents are not going to work there. But today we're seeing that world is changing very dramatically. 3 years ago, 4 years ago, when we had autonomous technology, people would say, I just cannot use this. Now it's become the exact opposite, where if you don't have autonomous, you're not even in that conversation. So there's a cultural shift that's happening towards autonomous as well, where it's more welcoming and there's tailwinds behind it. So if you put all of that stuff together, a lot of pieces can be made to run automatically, can be made to optimize automatically. And I think 60-70% of the problems get solved that way. What we are doing particularly in Unravel is we are creating persona-based agents for different problems on these data stacks. FinOps is one problem that we solve for sure, but we also solve performance and reliability and quality problems. So we actually have separate agents looking out for these things. In fact, when it's launched in companies, they actually give it names because it's like a team member that's actually on your team solving these problems for you. And it's the full loop there. So these agents are detecting the problems. They're telling you about the problem. They're root causing it. They're giving you the root cause analysis, what really happened, what impact did it have. Then it's going and figuring out the remediation. It's validating those remediation steps so that you don't have to do trial and error. And then it's presenting you like what you could be doing. And then the way you've configured it, you can say, I want to do it like a human in the loop. Don't take an action for me. Tell me, let me review it. I'll click yes. Then you go make the change, or it's just fully autonomous, right? So we have a FinOps agent, we have a DataOps agent, we have a data engineering agent, we have a data quality agent. And then all these 4 agents are also working in harmony, because on these data AI stacks, performance, cost, quality, reliability are like all combined problems. They're very highly correlated problems. So they have to talk to one another as well. And I think that's the way this is going to go, where you're on Slack and you're chatting with your DataOps agent about, like you would chat with Victor, like, Victor, did you check that pipeline out? What happened to that one? Or, we saw this cost go up. What went on? And it'll tell you, this is what went on. I've already taken care of this. Costs have come down now. Next will look like this. And I think that's where this world needs to go, is, just think about this as a new teammate rather than, a very fractional tool that only does one thing. I think every FinOps X that gets done. What I love seeing is there's a completeness of, I'm not just an informed company, I'm not just an optimized company, I'm not just a governed company, and I'm not just an AWS company, I'm not just an Azure company. So I think like all of those were like building blocks. You have to have the full stack view. You have to be able to solve problems at the infra and the code and everything else in between. Because if you're just doing siloed things, then that company is not going to treat you like a coworker and somebody who's the expert in the system. And they're not going to hop around like, how you used to hop around tabs. They're not going to hop around agents thinking about, oh, this can only solve this particular piece and, it cannot do anything else. So I think for the vendors especially, it's all about building the whole product. And when I say whole product, I mean the complete product with the user experience in mind, and really carving out for each persona what is it that persona wants to do, rather than building out a super agent that's good at everything but not great at anything.
Yeah, I think you frame it nicely. I believe that it's more natural to how teams are built. You don't have one person that is the magic wine and it does everything. You have a team, so you have a specialist build on, and then you build the right team to make the things. And someone is optimizing the pipeline, someone is securing them, someone is checking the quality and developing and creating, and someone is optimizing the cost. So I think it's it's always like having more resources in your team, having and letting people create the value, drive the business, and then automate as much as you can and help people. So I think this is a wonderful example of how to really use AI for a good implementation. So thanks for being here today.
Thank you for having me. This is fun.
Yeah, it was a lot of insights. I think people can learn a lot about how to do data platforms, and we'll let all the links in the description about what
and
they
maybe
can check.
Next time we do it outdoors in San Diego.
We can do it in the Bay because it looks amazing, and we can do it next to the Midway. It'll be a great interview.
Exactly.
So thanks.
Walking along the Midway.
That'll be a good interview. So thanks, Kunal, for taking the time, and see you everyone in the next interview. Bye bye.
Thank you.